Hello everybody. Today's lesson is going to be on secondary storage. My name is Josh and I'm putting together this series to give you as little as possible to remember in the GCSE Computer Science specs today. It's all to do with Cambridge International. We've got videos on the other specs, so please make sure that you check those out. And what I'm using is my knowledge as I was an examiner for 5 years. I've also taught thousands and thousands of students computer science, GCSE, A-level. I run a tutoring business. I was a teacher for a really long time as well. And what I see online is a lot of information that gives students too much. What I'm trying to do is give you the bare minimum that you need to do to still be able to access the top marks. And what I've done is I've related this all to the specification points. The specification points is everything that could come up in your exam. So my logic is if I give you all of the questions that I've seen and all of the answers, what the smallest amount that you can write to get the top marks on those questions, then there isn't any way that you can't get the top marks. And this then means that you can put more time into getting better at your programming in computer science or, working on other subjects. So this is what we're going to be looking at today. It's to do with secondary storage, and it's going to be looking at magnetic, optical, solid state, the different categories. We're also going to be looking at the cloud storage and advantages and disadvantages of the cloud. So the way that I've split this up is, so just very quickly, the question that they could give you is state the 3 categories of secondary storage, which is solid state, magnetic, and optical. On the next slides, what I've tried to do is, as you can see here, I'm talking about optical. The examples of this, again, I've just given you a couple so that you don't have to remember loads of them, because there's no point in remembering loads, because this is only going to be a 1-mark question or 2 marks. So with this one, so you've got CDs and DVDs. What it does say is that you have to be able to understand how optical works, and this is this sentence here in the spec point. So this is what you need to write down. So it's got a disc which spins, and a laser is shone at the disc. There are these things called pits and lands going out in a spiral from the middle. The laser reflection is measured when it passes over the pits and lands. This changes the reflection. And this is how it determines whether it's a 1 or a 0. With all of this, data is on the computer as a 1 or a 0. And you've got to know, in all of these different situations, how these 1s and 0s are represented. So that's optical. A hard disk drive. Now, this is all to do with magnetic. So an example that is the only one that is in use still is a hard disk drive, or HDD. You can put the acronym if you want. And how a HDD works is the disk is split up into tracks and sectors. As you can see, it's related to the spec point here. A read and write head goes over the different areas and reads whether the data is a 1 or a 0. So again, relating it to that 1 or a 0. Just a quick side point. If it does ask you to talk about why you would use one over another, pretty much in any situation, solid state is going to be the one that you would use. That is, in real life, the one that is everyone is going towards. The only situation that I can think of that you would use a magnetic over a solid state, and one that I've seen a question in, is where a company that has a smaller budget but needs something with a really large capacity to do backups on. In this case, what you're looking for is something that's cheap and has a large capacity. In this case, HDD would actually work very well and work better than solid state. So it might be worth just making a quick note of that. The final one is going to be solid state, which is also known as flash memory. So you can use those terms interchangeably. Now, the examples of this are SD cards, USBs, solid state drives. How it works is, the only real thing that you need to know is that it has these things called NAND gates, which we're relating this from the logic gates unit. How it works is that the electric current is either trapped by these NAND gates or not, and that determines whether it's going to be a 1 or a 0, which is read. So again, relating it to the 1 or the 0, the binary on there, which represents all of the data going on in a computer system. Final little point is we're going to be looking at the cloud storage. So let's get a quick definition for cloud storage, which is cloud storage is where the storage is not actually held on your device, but on a remote server in another location. This all requires an internet connection. So it's this idea that your files are no longer local on your device. They are somewhere else. And that would be Office 365, Google Drive, these massive companies which we store files on. You also need to know the advantages and disadvantages of these. So the pluses are the positives, and the minuses, the ones next to them, they are the disadvantages. So the pluses there we've got is you can access the files from any device as long as you have an internet connection. It's easier to collaborate with other people. The negatives, though, is that it has to have an internet connection to access the information. So some people do not have this, and this isn't a possibility. We're also trusting a third-party company with the security of our files. So it's not, whilst they may have really, really good security measures, we are still trusting them that they are going to be upholding their end of the bargain. Now, what I want you to be doing, people, is please make sure that you're doing maintenance activities, because either this isn't going to get processed into your long-term memory. Put flashcards. Practice these. You only need to be doing, 15, 20-minute slots of just going over so question on the front, answer on the back. Okay?